Hello, today we're going through some applications, examples and definitions about insulators and conductors. So what are conductors? Well, conductors are materials that have free electrons that can easily move through its structure. Good examples of conductors are metals, they are solid conductors. We have salty water, a liquid conductor, and ionized gases, a gas conductor, the same gases we find in these fluorescent lamps. Insulators, on the other hand, are the opposite. They are materials that do not have free electrons. Some examples are rubber, chalk, and glass. The electrons and ions in insulators, they are bound in the structure and they cannot move easily. Remember that I told you that salty water is a good conductor? Well, it's a good conductor because you have free electrons in the water. However, if you take dry table salt in a solid state or pure water, these are actually insulators. They're not good conductors. Remember, we're talking about pure water, just H2O. Let's now talk about charging processes of these materials. First one is friction. And friction is a charging process that we use in insulators. A good example is when you rub a balloon all over your hair and it gets attracted by the balloon. I'm not going to cover this example here because I've already covered it in another video, the electric charges video, so I suggest you to go there and see how it works. The second charging process is by contact, and we do it with conductors materials. Imagine you have a sphere, two spheres, two conductors. One of them is with a negative charge and the other one has zero charge. If we touch them, now they're going through an equilibrium, and the second particle that had no charge now has a negative charge also. You can notice that the charge of the first particle changed from -12 to -8, and the second one now has a -4 charge. It happens because of the conservation of charge that I've already covered also in the same electric charge video, so I highly recommend you to go there and take a look. One thing for you to think about is what happens if two charged insulators touch. Imagine you did a charging process by friction with two insulators and you touch now one of this electric charged insulator in another one with no charges. What happens? The last charging process we're going to cover is the induction process. Let's divide it into 4 simpler steps to understand it. So in the first step, we have a positively charged rod that is brought near a neutral metal sphere. When you do it, we polarize the sphere. So the positive rod attracts the electrons from the sphere to its side, leaving all the positive charges of the sphere on the other side. The sphere then is grounded, and when we do it, we allow the electrons to be attracted from the Earth's ample supply. So the sphere attracts some of the electrons of the ground, but then we cut the connection, so we don't have this supply anymore. The sphere has attracted all these electrons, the negative charges, to itself, But now we don't have the supply anymore. And then, if we take the rod out, if we remove this positive rod, we leave the sphere with an induced negative charge. Now I want you to think about this example here and then write your answer in the comment section. So we have two liquids, hexane and water, and an electrified rod. If we put the electrified rod near the hexane, nothing happens. However, when you do the same for the water, we can see that the water gets attracted by the electrified rod. Can you explain what's happening here? It's your turn. Comment and thank you.
Now that you understand the basics, we can cover even more advanced topics. Like this video and let's move on to the next one.